The first attempt to catch the petrological study of rock always begins with the serious study of thin sections to study the nature of minerals and to analyze mutual relation of these minerals. No petrological study can be complete without an understanding of textural and structural development of the rock. Interpretation of textures and microstructures is important to understand evolution of rocks. The texture of a rock is the result of various processes that control the rock's genesis and along with mineralogy and chemical composition. Some confusion exists and many authors do not distinguish clearly between these three concepts, which are texture, structure, and fabric.
During studies of texture, students are normally confused to distinguish between texture, microstructures, and mutual relationship of grains, that is fabrics. Basically, texture means whenever we study a rock under thin section, whatever texture or a structure is present within a rock is come under category of texture. Similarly, the same textures when we study on hand specimens or on outcrops, that is known as structures. The mutual relationship, or in other words we can say the combination of crystallinity, granularity, textures, structures give the idea of fabric of a rock. And on the basis of fabric of rock, we can predict the origin, type, and genesis, even genesis also for a different rock.
First of all, texture. Texture refers to specific intermineral relationship that may be repeating throughout the rock. Secondly, structure. Structure has two meanings when applied to igneous rocks. First, It can refer to certain large-scale features such as lava, pillows, etc. Or it denotes small-scale features that affect the rock. These include color banding, flow banding, and joints. All these elements fall within the realm of structure geology. Thirdly, fabric. Fabric is overall aspect of the rock which results from a combination of textural and structural elements. Fabric is influenced by texture together with the shape of components. The 5 basic parameters are required to describe the texture of rock. These are as follows: color, crystallinity, that is the degree of crystallization, granularity, the absolute size of crystal, crystal shape, texture, the mutual relationship of crystal, we start with color. Every rock sample should be classified according to color using the following scheme. Leucocratic, less than 30% dark minerals present. Mesocratic, 30 to 60% dark minerals present. And melanocratic, having greater than 60% dark minerals. This is purely a reflection of minerals color and is independent of the subdivision into felsic, mefelsic and mafic. That is acid, intermediate, basic and ultra basic, defined by the type of mineral present.
During petrographic studies, the study of rock under microscope, the texture play a very important role during study of a igneous rock, because on the basis of texture we can predict depth, composition and nature of a rock. Texture is nothing, it is a combination of different minerals. Say for example, if dunite rock is there, the only mineral present in dunite is your olivine and the texture is your cumulative. Similarly, if directive texture is present in a igneous rock, that indicate about the movement direction of a magma. Say for example, if granitic rock, it means the rock must be holocrystalline, phenric, having equigranular texture or inequigranular textures like porphyritic granite. We can say, while we will write the mutual relationship or fabric, rock is a holocrystalline, phenric, showing porphyritic textures where the phenocrest of potash feldspar are embedded in a fine grained ground mass. So, in this way we can find out or we can identify the fabric of a rock.
Secondly, crystallinity. Crystallinity is the ratio between crystallized to non-crystallized materials. They are the following types. First of all, holocrystalline. When rock is mainly composed of crystals only, that is well-developed crystals, it is therefore known as holocrystalline. Hemicrystalline. When rock is composed of both crystals and glass, it is called hemicrystalline. Sometimes it is also called mesocrystalline. Holohaline. When rocks are formed by completely or entirely by glass, it is called holohaline. Now we deal with significance of crystallinity. Plutonic rocks are holocrystalline, hyperbasal rocks are mostly holocrystalline, whereas many volcanic rocks are hemicrystalline or even holohaline. Rapid cooling and high magma viscosity favors glass formation, whereas slow cooling and less magma viscosity promotes crystal growth. Color and granularity above refer exclusively for hand samples, while crystallinity refers to both hand samples and thin sections. Crystal shape refers to both hand sample and thin sections, whereas texture refers mainly to thin sections. Even holohaline rocks may be contain minute embryonic crystals. There are two types: crystallites and microlites. Crystallites, embryonic crystals that cannot be resolved under the microscope, can be called as crystallites. Microlites, slightly larger crystals whose optical properties can be identified. Their shape classifies these minute crystals: globolites, longuolites, scopiolites, margarites, trichides, and microlites. Glass is a supercooled viscous solution with no regular molecular arrangement. It is therefore unstable and tends to form fibrous crystals with the passage of time. This is referred to as devitrification. Granularity. Crystals range in size from microlites to meters. However, the general classification is based on visibility with naked eye. These are mainly two types: aphanetic and phaneric. Aphanetic, when individual crystals cannot be identified by naked eyes. Aphanetic texture, the small crystals that cannot see by eyes or with the help of hand lens, known as aphanetic texture. The entire rock made up of small crystals, which are generally less than 1/2 mm in size. This type of texture usually found in volcanic or hyperbasal environment formed by rapid cooling. Aphanetic rocks are characterized by textures in which the mineral grains are not visible, while mostly aphanetic rocks have at least a few phenocrysts, small or larger grains. This often causes or confuses the student to assume a phaneritic texture, but with a little practice, you can quickly distinguish between aphanetic and phaneritic textures. The dark rocks like gabbro are more problematic. Aphanetic rocks may be holohaline, hemicrystalline, or microcrystalline. That is, individual crystal can be distinguished with the aid of a microscope. They can be cryptocrystalline. Individual crystal cannot be resolved under microscope, yet the reaction to polarized light indicates their presence. spherocrystalline or pheneric rocks. When we identify and distinguish the individual crystals by naked eyes, example of pheneritic rocks show a hand sample and a thin section of pheneritic textured rock. Pheneritic textured rocks are composed of large crystals that are clearly visible to eye with or without a hand lens or binocular microscope. The entire rock is made up of large crystals, which are generally 1 by 2 mm to several centimeters in size. No fine matrix material is present. This texture forms by slow cooling of magma during the plutonic environment. Now, phenocrystalline rocks can be further subdivided on the basis of crystal size. Coarse grain, when average crystal diameter is less than 5 mm. Medium grain, average crystal diameter vary from 1 to 5 mm. Fine grain, when average crystal diameter is greater than 1 mm.
During field studies, the igneous rock identify on the basis of color, mineral composition, and if special textures are present like porphyritic texture, then on the basis of texture present, mineral composition, directly we can name in field the rock is volcanic or plutonic. Maybe a porphyritic showing, in other words, like directive texture.
Now, after discussing granularity, we start crystal shape. The overall fabric depends largely on crystal shape. This can be defined in two ways. First, by reference to development of crystal faces, and by referring relative crystal's dimension to the three directions in space. Now, crystal faces. The crystal face may be grouped or classified into following types. First, euhedral, when crystals are completely bounded by crystal face, is known as euhedral crystal. Second is subhedral, when some faces partially develop but not all the faces, is known as subhedral. Third is anhedral, when crystal faces are totally absent, often due to other crystal interfering with their growth, is known as anhedral. Now we discuss direction in space. It depends upon the type of mineral present. First of all, equidimensional. When crystal more or less equally develop in every direction, it is known as equidimensional. Tabular. When crystal develop in two spatial directions, is known as tabular. Example is feldspar. Prismatic. When crystal best develop in one direction, is known as prismatic. Example, hornblende.
One very basic question is asked, that is, give a detailed account of texture of igneous rock. Even in short notes like porphyritic texture, reaction rim, write short note on polylytic textures, etc. So, normally there may be a full length question based on texture or short note questions based on individual textures.